As part of the topic on areas and perimeters of three-dimensional shapes, we are in particular going to focus on the perimeter and the area of circles. Firstly, let's just study some terminology regarding the circle. We know at the center we have the midpoint. Then we have the radius. It's from the midpoint to what we call the arc. The arc is like the boundary of the circle. So the arc usually connects two radii. Then if you look at the area between the two radii and the arc, we refer to that as the sector. The circumference of the circle is like basically a synonym for the perimeter of the circle. It's the length all around the circle, if we measure that. So that's the circumference. The diameter we can write as 2 times the radius, because it is the radius from the arc or the circumference of the circle right to the midpoint, through the midpoint to another point on the arc of the circle. So we could also say that the radius is in fact half of the diameter's length. So now the area of a circle is pi radius squared, where pi we can approximate by 22/7 or 3,142, etc. In fact, pi has an infinite number of decimal places following it, and there's no repeating pattern. So the circumference or perimeter of a circle is 2 pi radius. The easy way for me to remember the perimeter once I know the area is simply to take the 2 that stands the square, that represents the square, and take it to the front. So then it becomes 2 pi radius as the circumference. So let's use activity 16.2 to illustrate the application of area and circumference. So for number 1, we have to calculate the circumference and the area of a circle with firstly a radius of 83 centimeter. So let's first calculate the area. Area is pi radius square. So we could now replace pi by 22/7. The radius is 83 centimeter. We still need to square it, so it's simple substitution. So you can use your calculator. So 83 times 83 is 6,889, and that you still have to multiply by the 22 and divide by 7. So times 22 divided by 7 will give you 21,651,14 centimeter square. Remember, area always expressed as square unit, and centimeter times centimeter is centimeter squared. This is now rounded to 2 decimal places. Let's go and calculate the circumference. We said the easy way to remember is just take the square and move it to the front in terms of the area. So it's 2 pi radius. So we have now 2, and pi is now 22/7, and radius is still 83 centimeter. So we can simply multiply 83 on our calculators by 22, divide by 7, and multiply still by 2. And then you should obtain 521,71 centimeter. In fact, sometimes one also have to be led by the question. This one is now not as explicitly in how to deal with this, but pi is more accurate than anything else. It represents something precisely. So what you also could have done, which is actually the most accurate answer in a sense that you could give, is to say 83 times 83 is 6,889, and we still have to multiply by pi. So this is actually the most accurate answer. But sometimes it will be asked for you to use 22/7 as pi, or 3,14 or 3,142. So you have to be guided by the question when it explicitly indicates to you how to deal with it. So similarly here, we could just say 2 times 83. 2 times 83 is 166 pi centimeter. That would be the most accurate answer in a sense. Well, not in a sense, it will definitely be the most accurate answer. So let's deal now with number B. So it's the same question, just a different measurement. We have now a diameter of 257 millimeter. Now we need to know how radius and diameter are related. So the radius is equal to half of the diameter. So we could say therefore that our radius is half of 257 millimeter, which is 257 divided by 2, 128,5 millimeter. Now we can use that again and replace it into our formula for area. So we could in fact say that the area equals pi. In the place of r, we have now 128,5 millimeter squared, which is equal to, let's see, what's 128,5 times 128,5. Use your calculator, it will give 16,512,25 pi millimeters squared. Okay, if you want a less accurate answer but are required to use maybe something like 22/7 in the place of pi, then it would be 16,512,25 over 22 or times 22/7 millimeters squared. So we have to multiply 16,512,25 times 22, divide by 7, and it will in fact give us an answer of 51,895,64 millimeters squared to 2 decimal places. So if we focus on the circumference or perimeter, it's 2 pi radius, and now we have 2 pi. In the place of the radius we have the 128,5 millimeter. So 128,5 times 2 gives us 257 pi millimeter. And again, we can replace pi by 22/7, so we could say it's 257 times 22 divided by 7 if we are instructed to give an answer maybe to 2 decimal places. Then it would be 807,71 millimeter. Number 2 of activity 16.2, Findy is an athlete. As part of the training, she runs around the outside of a circular track. If we think outside, we think, yes, circumference or perimeter, areas inside. So outside, perimeter or circumference. That has a radius of 88 meters. How far does Pindy have to run to complete one circuit of the track? Give your answer to the nearest meter. So one circuit means simply calculating the perimeter. So let's do that. So perimeter we know is 2 pi radius, or circumference is 2 pi radius. So it's 2 times pi times radius, and in the place of radius we have now 88 meter. So we have 2 times 88. 2 times 8 is 160. 8 times 2 is 16. 160 plus 16 is 176. So it's 176 pi meter. Okay, but in this particular question they want it to the nearest meter. So that implies we have to replace pi with something like 3,14 or 3,142 or 22/7 to get an approximation, since we want it to the nearest meter. So we can take the 176, multiply by 22, and divide by 7. And we will obtain 553,14 meter to 2 decimals, which is to the nearest meter, 14. 553,14 is closer to 553 than to 554. So it's therefore 554 meter to the nearest meter. So now let's look at number B. As part of a training, Wendy needs to run 12 kilometers on the track. How many circuits of the track will she have to run? Give your answer to 1 decimal place. Well, so now we have to take 12 kilometers is how far she has to go, and divide it by the distance of one track to see how many times one track goes into the 12 kilometer, to see how many times she has to run along the track. So the problem is now that we have meters versus kilometers, so we will first have to change meter to kilometers, or alternatively change kilometers to meter. I'm going to change kilometer to meter. So kilometer, we know 1 kilometer is how many meters? Yes, 1,000. So wherever we see kilometer, we can replace it by 1,000 meter. So we have now 12, not kilometer, but replace by 1,000 meter. So 12 times 1,000 is 12,000 meter. So now we can divide the 12,000 meter by the 554 meter, since they are the same measurement size. Meters can cancel, so let's see how many times does 554 go into 12,000. So if you use your calculator, we have 12,000 divided by 554, and that gives us 21,66. But we have to round to 1 decimal, so 6 is larger than a 5. And remember, we look at the neighbor to the right. So after the first decimal, the neighbor to the right is a 6, bigger than 5. So the decimal we are interested in, the first decimal, we have to add 1 to it. So 6 plus 1 is 7. So it's 21,7 times that she has to run around the track to cover 12 kilometers. So for number 3, David wants to cut a circular tabletop from a square piece of wood that has sides of 1,800 millimeter. You can see it's illustrated in the sketch. What is the area of the largest circular tabletop that you can cut from the wood? Give your answer in square meter. So you are going to have to convert from millimeter to meter to 2 decimal places. Now there are more than one way that we could approach this. The one is to first change the millimeters into meters. The other one is first to do the calculations in millimeters and then in the end change into meters. Both should provide the same answer. First thing that we should probably notice is, since this is a square piece of wood, that this distance, see here that circle touched the square, here it touched the square, so that distance, that straight distance, is in fact equal to 1,800 millimeter. So the radius is in fact half of that. So we know in fact that R equals 900 millimeter. Okay, so the approach that I'm going to do is I'm from the start going to change this to meter. So we know how many millimeters in a centimeter first of all. 1 centimeter is how many millimeters? Yes, 10. So we also know there are many millimeters in a centimeter. So if we want to go from millimeters to centimeter, we will have to get a smaller answer. So we will have to divide, therefore, to get a smaller answer. So 1800 divided by 10 gives us the answer in centimeter. We can cancel 0, so it's in fact the same as 180 centimeter. Can do the same with the radius. It is in fact therefore 90 centimeter. In fact, I'm not even sure why I was dealing with the 1800, because we want area. You know, area of a circle is pi radius squared, so we just simply actually need the radius. We should only focus on the radius. So we have a radius of 90 centimeter. We want meter, so now the question is how many centimeter in a meter? So 1 meter is 100 centimeter. Again, there are many centimeters in a meter. So if we want to go from centimeters to meter, we expect meter must be a small answer. So again, we will have to divide. So we have to divide 90 by 100 to get the answer in meter. Because division makes something smaller. So we could cancel 0, so we have 9 out of 10. We actually have an invisible comma 0. When we divide, we jump to the left, the comma 1 jump, because there's 1 0 remaining. So it's in fact 0,9 meter. And now we can just substitute in our formula. So we have pi. In the place of radius 0,9, we still have to square. So can replace the 1 to 2 decimals, so we are going to use approximation. So replace by pi by 22,7 or 3,14 or 3,142. Usually they will indicate in the test or exam what to use so that everybody uses the same thing. But in this case, I'm just going to use 22 over 7. We still have to multiply 0,9 by itself. So 0,9 times 0,9 gives us 0,81. So 0,81 times 22 divided by 7 will result in 2,545 square meter. We want to 2 decimals. Here's 2 decimals. Look at the neighbor at the right. It's 5 or bigger, meaning the one we are interested in needs to increase by 1. So it's 2,55 meters squared. So number 4 of exercise 16.2, we have a goat and it's tied to a post by a rope. The rope measures 6 meters. Calculate the area of grass that the goat can reach to the nearest meter squared. So we want to calculate the area, and obviously this goat can form a circle of 6 meters by running around the post. So therefore the radius is in fact 6 meters. So we want the area. So area equals, I think I'm going to give you opportunity to try this one on your own. Okay, for those that maybe can't recall, the formula for area is pi radius squared. So now we know the radius is 6. We want to the nearest meter, so it's approximation, so we won't just leave the answer in pi form, the most accurate form. We will rather replace it. Let's replace it by 22/7. You could also use 3,14, 3,142. Radius is 6 meter. We have to square. 6 times 6 is 36. So in fact it is 36 times 22 divided by 7, which will result in 113,14 meters square. But we want to the nearest meter. Here's the nearest meter. Look to the neighbor to the right. It is a comma 1. It is smaller than 5. So just cut off that part. So it's simply 113 square meter. So, number 5. Sandra wants to make a circular enclosure for her goats. She has 63 goats, and each goat needs an area of 250 square meter. What length of fencing does Sandra need? Give your answer to the nearest whole meter. So now, if each goat needs an area of 250 square meter, the question is, what area does 63 goats need? Well, it will be 63 times 250 square meter. So we first have to multiply 250 square meter by 63 goats to get the total area that is required by the goats. So what's 250 times 63? 15,750 square meter. So now we need the circular enclosure with that area. We know area is pi radius squared. So we can now first determine the radius. So we know the area. We can replace area by 15,750. We have to calculate radius. So let's approximate, because we want to the nearest whole number, pi. I'll use again 22/7. Radius squared, I don't know. But now I have an equation. I can solve R. How do I do it? Well, I have to get rid of 22 over 7. How do I do that? If I multiply the top by 7, these 7's will cancel. If I divide the bottom by 22, these 22's will cancel. What I do to the right, I have to do to the left. Oops. So the left, I will have to also multiply by 7 over 22. So now we simply have radius square on the right, what we wanted all along. We can take the 750, multiply by 7, divide by 22. We will obtain 5011, 36 recurring. And now we don't want radius square, we simply want radius, so the opposite of a square is a square root, so that they cancel, so that we simply have radius. What we do to the right, we do to the left. So you can use your calculator to determine the radius of 5000, or the square rather, root rather, of 5011 and 36 or 36 recurring. So we have the square root of 5011.36363636 recurring, which gives a radius of 70,79 meters. Okay, but this is the radius, that's not the length of the fencing. So remember, we have the circular fence, we have now the radius of 70,79 meter. We want the fencing that is needed. So now we need to calculate the circumference, because that will give us the length of the fence all around. So circumference we know is 2 pi radius. And now we can replace the radius with the 70,79. So it's 2 pi we can replace with 22 over 7 as approximation. Radius is 70,79. This is all meter. So now we can use our calculator to simplify. So in fact we have 2 times 22 divided by 7 times 70,79, which will result in 444,9 meter. But we have to round to the nearest whole meter. Whole meter is our ones. Look to the right. It's larger than 5, so add 1 to the one we are interested. So it's 445 meter. That's how much fencing will be required.